In this video, we're going to be looking at absolute convergence, and we want to determine if the series is convergent or absolutely convergent. And we are essentially going to perform 4 different convergence tests in this video, 2 for each problem. So, on the first version of this problem, or the first series we encounter, we're looking at the sum from n equals 1 to infinity of 2n cubed plus n squared, all of this times minus 1 to the n plus 1 over 2n to the 4th plus 3. And so the first question we want to ask is if it's convergent. And we first note that the minus 1 to n plus 1 makes this an alternating series, so the alternating summation test is the most straightforward way to determine if this is convergent. And we also note that without the alternation, the expressions are simply cubics divided by quartics, and things like that converge to 0. So, since the limit as n goes to infinity of 2n cubed plus n squared over 2n to the 4th plus 3 is equal to 0, and there's a number of ways to see this. We can compare the cubics to the quartics, or we could just apply the L'Hopital's rule. Either way, we get 0. This series is convergent by the alternating series test. All right, so the second part of this is to determine if the series is absolutely convergent, which means we take the absolute value of the expressions and see if that converges. If I take the absolute value of the expressions, I'm essentially just getting rid of this minus 1 power business. I'm looking at a cubic over quartic. And that starts to resemble 1 over n, right? Because we have a power in the denominator that's only 1 greater than the power in the numerator. And so it starts to look like a harmonic series which diverges. So our expectation should be that this series will diverge without the minus 1. So note, since I want to compare the series without the minus 1 to the n to the harmonic series 1 over n, it makes sense to just invoke the limit comparison test. Since the limit as n goes to infinity of our series, which is this rational expression, divided by the harmonic series terms 1 over n, which I will quickly rewrite in a more legible format that is easier to work with. Just simply divide by reciprocal n equals 1, which is the limit as n goes to infinity of, we can just distribute this n through 2n to the 4th plus n cubed over 2n to the 4th plus 3, which is 1, right? We have the same leading terms, so their quotient is 1. L'Hopital's rule would also do that, etc. And well, we know that diverges. So the sum n equals 1 to infinity of 2n cubed plus n squared over 2n to the 4th plus 3 diverges and the series is not absolutely convergent. And so what we did here, in case we wanted to be very particular, is by the limit comparison test. All right, let's take a look at the next series. The next series is the sum from n equals 1 to infinity of 5 times minus 1 to the n plus 1 and over 2 to the n. And we want to know if this is convergent or divergent, or is it absolutely convergent? And so for convergence, we once again note that this is alternating and that the remaining sequence, the terms 5n over 2 to the n, that goes to 0. The L'Hopital's would show you that as what we note by just comparing an exponential to a linear term. So the series converges by the alternating series test. And then, if I just want to know if the series is absolutely convergent, taking the absolute value of these expressions simply drops to minus 1 to n plus 1, and I want to know whether or not that converges. I am comparing then a linear expression in the numerator to an exponential one in the denominator, and this suggests to me that the ratio test will tell us that this will in fact converge when I take the absolute value. And so we should also note, since the limit as n goes to infinity of 5n plus 1 over 2 to the n plus 1 times 2 to the n over 5n is equal to the limit as n goes to infinity of 1/2 times, right? We 2 to the n plus 1, we are left with a half, and then 5n plus 5 over 5n, and that converges to a 1, which is 1/2 is less than 1. By the ratio test, the sum from n equals 1 to infinity, 5n over 2 to the n converges. And the series is absolutely convergent. All right, thank you. I'll see you in the next video.